Okay, so this is part 3 of what was supposed to be a short tutorial on how to do some coding for neural networks using TensorFlow and Keras. And we've got down to the point where we are optimizing the hyperparameters, so learning rate and number of neurons in each layer and the number of hidden layers. So the number of hidden layers is going to go from 1 to 3, number of neurons from 1 to 100, and then a learning rate. And I had just looked at this scikit optimization, which we actually don't need for this part. We're going to bring that in a little later. And we started this randomized search, which cross-validation. And so I described the Bayesian search while we were started this, but this took a long time. It took 15 minutes to optimize. So I cut out partway through that. Actually, my battery died on my computer, but I'm plugged in now. And so we did this randomized search, and we gave it the parameters and the parameter distributions here. We said we're going to do 10 iterations of this. So we're going to pick 10 random sets of those. We're going to do threefold cross-validation, and then up to 100 epochs when we train, and we're going to do some early stopping where the patience equals 10. So we'll see. Just take a little look at the output as it's training. So epoch 1 up to here, it ends at 24. This was the last of the 10 iterations. And it says, as it was training, these are all the values it ran through. Here were the number of hidden layers. This was the possible values for the number of neurons, and the learning rate. It was given by that reciprocal function. And we come down here, and the best parameters that we found using that cross-validation random search, a learning rate of 0.0033, 2 hidden layers, and 42 neurons per layer. And the best score for the mean squared error for that best model was 0.3168. And then this is how we get the best estimator, and we could run that random search optimized model on our test data, and our loss on the test data is 0.3182. And that's notably anything that we saw better than anything we saw previously. So we get a good model this way. Okay, now we're going to actually use this scikit optimizer, SCOPT, and we're going to do another optimization. We're going to implement the Bayes search using cross-validation. And remember, the idea here is that it'll search our parameter values, but it'll optimize searching places where it hasn't searched before, as well as searching places that were near a maxima, and it'll try to do more searching either around a maxima or places it hasn't searched. So when we have our 800 different values, where it's 3 times 100 times 4, so that would be 300, 1200. If we're going to run this, it would take about 2,000 minutes. I don't know, that'd be a long time if we were going to do a full grid search. But with the Bayesian optimization, it optimizes to search the best places, and it found its best model had 3 hidden layers, 93 neurons in each layer, and a learning rate of 0.005. And let's see what the best score for that model was 0.3. And then we want to apply this to our test data, and we get a mean squared error of 0.287. And just to compare that, it was 0.312 for the model optimized with a random search, and 0.287, significantly better. So that's really shows the benefit of using the Bayes search. And really, if I ever built a neural network for anything that I want to do well on, I'd always optimize the parameters with a Bayes search, the Bayesian optimization search. So I hope that was helpful. Thank you for for following for this long. Have a great day. Happy TensorFlow, happy Keras, happy deep learning.